Hello students, am I audible? Live. Live. Checking the volume. Am I clearly audible? There is no disturbance. Quickly let me know in the chat box. Right? No disturbance, right? Quickly let me know in the chat box. Yes, no disturbance. Clearly visible. Slide is visible. Right? Everything is visible, right? Okay, I'm also going to check the volume once. Yes. Hello students, welcome to Unacademy NEET English channel. I am Miss Gopika, your biology educator. So can we start the session? Yes. Good afternoon. Good afternoon. Okay. Students, quickly share the link with your friends because this is not the number I expect. There should be more students. So quickly share the link with your friends and ask them to join. Okay. Ask them to join. Remind them on Telegram as well. Okay. Yes. Let's start the session. Okay, students, last time I told you that I will only release the part 3, right? I'll only release the part 3 of plant growth and development only if you people comment and like the session. So you people have done a good job. That's why I'm here with part 3. Otherwise, I wouldn't have. Okay. So yes, on a serious note, I wouldn't have. Okay. So yes, good afternoon. Good afternoon. So students, we have a clarity. Okay, I cannot see the numbers increasing. That means you people are not sharing with your friends, which is very bad. Okay. So students, yesterday we discussed about the syllabus, we discussed about the eligibility. So I hope we are all clear about what is happening, what NTA is informing us. So every time Unacademy needs English, we are trying to update as much as possible. Even I am updating on my Telegram channel. So you do not, miss out on anything, right? So now our only job is to prepare and, to kickstart our preparation in a very, very energetic manner, because now that the syllabus is out, most of the students are making excuses telling, oh ma'am, syllabus, let the syllabus come, then I'm going to start preparing. Now that everything is available, there is no more excuses. Only job is to start the preparation. Okay. So we are completing, like we have finished photosynthesis, we have finished respiration, we have finished the MCQs. According to our sandwich classes, we have finished everything about photosynthesis and respiration. Students who attended the session and are a part of the leaderboard, I know all of their names. Okay, those who haven't attended, it's really, really disappointing because it's your high time to start your preparation. Okay, fine. So students, last class, plant growth and development, right? We understood relative growth and absolute growth, right? We understood how to calculate relative growth, how to calculate absolute growth, and we also did the problem that what was given in your NCRT. So we saw one leaf which was 5 centimeter, it grew up to 10 centimeters, so it was a 100% growth, right? And then we had another case, that is a second scenario where we had a leaf which was around 50 centimeter and it grew 55 centimeters. So here the growth was 10%. So we calculated it by, first we calculated final minus initial, and in the second case we did, or your relative growth, we did final minus initial by initial into 100%, right? All of you remember all this calculation? Yes or no? Yes or no? Yes. Students, I'll be doing the families as well. Okay, I told you I will be doing the families, chikungunya and dengue. Okay, so everything is going to happen slowly. From Monday, I will start. Okay, families will be done. Do not worry about the families. Okay, it will be done in this channel, but you have to be regular in the channel, right? I am very regular in the channel. I'm very consistent, but I do not see all the students. Most of them, I do not see very consistent. Okay, yes, fine. So students, let's start. So here now today's topic, what we are going to do is a very important topic. Okay, it's a very, very important topic. It is, so before I start, okay, we are going to understand the conditions of growth. Okay, last class we could not do this. So today we will do the conditions of growth. Now all of you tell me what are the conditions of growth. That means basically if you want a plant to grow, or you are growing a seed, okay, you're growing a methi seed or some seed you want to grow, a mustard seed. What are the normal things that you will provide for the plant? Without any knowledge in biology, what are the things that you will provide for the plant? What are the things you'll provide for the plant? First, water, right? Water is the first factor. Agreed, all of you? Now, when we talk about water, what do we understand about water? Water is the medium, right? It is the medium for everything to happen, right? It behaves like a medium. What do I mean by medium? If some transport has to happen, water should be there. If nutrients has to go from one place to another, water has to be there. So water behaves like a medium, right? What are the other things, students? What are the other things? Wow, very good, very good. Water, yes, water, nutrients, right? Those, they are very, very important. Okay, nutrients, right? Now, when we talk about nutrients, what do we talk about? Macronutrients, micronutrients, right? We talk about nutrients that has to be needed in large amount, okay? And then we talk about nutrients that has to be needed in lesser amount, right? Yes, very good. Light, correct? Light. Without light, how will anything happen? Photosynthesis will not happen. Growth will not happen. Nothing, right? Nothing is going to happen without light. So light becomes a very, very important factor, right? Other than that, students, other than that, oxygen. Okay, other than that, we have oxygen. And when we talk about, say, growth, right? When we talk about growth, we talk about even oxygen. Why? Because we need it for respiration, right? We need it for respiration. Okay, we need it for respiration. Fine. Okay, what else do we have? What else do we have? Did we miss on anything? Yes, we missed on optimum temperature, right? Optimum temperature, because if temperature is not optimum, what is going to happen? Yesterday I discussed with you people in photosynthesis. All of you remember? All of you remember? Students, also understand, when we talk about conditions for growth, right? Any of this could be a limiting factor, right? Any of this could be a limiting factor. That means even if one nutrient is, say, 0.01% less also, that can become a limiting factor. That means anything can inhibit the growth. Anything can inhibit the growth, right? If you grow a plant, like if you've noticed money plants which are kept in our rooms, right? People do it for decoration. They keep it in the rooms. The growth of that money plant, you can notice that after some time the leaves start turning yellow in color, right? Have you all noticed? The leaf will start turning yellow in color. Why? Why is that happening? Okay, same way, if you keep the same plant in sunlight for like a high intensity light, even that time the leaf will start turning yellow. Why? Because we have damaged the chloroplast. Correct? Yes. Good, 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 good job. Okay, so these are the conditions for growth, right? These are the conditions for growth. There is not any, there's no, big things to study about this. Just understand water is the medium. At the same time, they make sure that the cell is turgid. Why the cell has to be turgid? Because we need to undergo elongation, right? The cell has to increase in size. So turgidity will help. Okay, so increase in size, right? Who is going to help? Turgidity is going to help. Clear to all of you? Okay, students, there might be a delay in the writing, but do not worry, it is going to appear, okay, within a few seconds. It is a very small delay, microsecond delay. Okay, clear? Is there any doubt? Any doubt? No doubts, right? Okay. Now that we have understood all the conditions that is necessary for growth, now we are going to understand what NCRT is telling. Okay, we will just look at NCRT because we know that we don't want to go behind NCRT again. We will finish everything at one shot, right? So here, what and all things they have mentioned. All of you mentioned everything. Very good job. Water, right? Water, oxygen, nutrients are very, very essential for the elements of growth. The plant cells grows in size by cell enlargement, which in turn requires water. Okay, this is where turgidity comes in place. All of you have noticed turgidity. If you now imagine night, right? Okay, today night you are deciding, okay, I want to be healthy, so you're putting all this almonds, your raisins, everything in water. Tomorrow, if you come and see what happens, they would have swollen, right? They would have swollen. That means what? The inside cells have reached turgidity. They have reached the maximum. All of you have noticed this? Yes or no? Very live example. Very live example, right? If your parents want to make the channa curry, right? They overnight, they soak it overnight. Why? To soften it, right? To soften it. Okay. Yes, very good. Now, turgidity of the cells help in extension, growth, extension. Everything is about growth. So whatever is we are talking is about growth. Okay. Plant growth and further development is initiated linked to water status of the plant. So how much water is there? Even if you pour lot of water also, there's a problem. Most of the students, I mean, not only students, everyone in general, including in my home, what happens is, if we do not, like, imagine you got a very beautiful flowering plant. First 5 days, you will have the high energy of taking care of this plant. After 5 days, you would have lost the interest. Okay, you would have been like, oh, going to pour water. It's okay. It is going to grow by itself. It's after all plant. I have studied so much about plant, right? After that, your parents will scold you, right? 2-3 days later, your parents will scold you. That time, what you will do? You will take one bucket of water and you will pour the water, telling them for 1 month you do not ask me for water. Students, will the plant grow like that? You will pour one bucket of water to the plant and you will tell for 1 month you're not going to make me get scoldings from my parents. So you're going to utilize this water. Does this work like that? Does it work like that? Will the plant be like, oh, this boy or this girl has poured one bucket of water for 1 month. Now I'm going to take 5% of water, 10% of water. Slowly every day I'm going to use the water. No, right? It does not work like that. When you pour more water, also the plants are going to respond in a negative way. Right? Whatever is essential only we should give. We should not give extra. Yes. Yes, very good. They'll get wilted again, right? So again, you're going to get scolding. So your life will not change after you pour one bucket of water also. Okay, this is the moral of the story. Okay, thus the plant growth and further development is initiated linked to the water status of the plant. Now, water also provides a medium for enzymatic activity. This is what I spoke about, medium. Okay. Now, oxygen also is required by for respiration, definitely, and metabolic energy essential. Nutrients like macro and micronutrients are essential. In addition, every plant organism should have an optimum temperature. Okay, it needs an optimum temperature for growth, and any deviation from this range could detrimentally to its survival. Students, I forgot one thing, very, very important thing. We all forget it every single time. Who you know? Gravity. We keep ignoring gravity, telling that, oh, you're always there. Why will I worry about you? Students, gravity. Okay? Gravity. What about gravity? Your negative, right? Negative phototropism and positive phototropism. Gravity is there. That is why it is telling the stem, no, you do negative geotropism. It is telling the root to do positive geotropism. If gravity did not exist, the plants would have been ulta, right? Ulta. Anyways, they would have grown. They would have grown like this. They would have grown like this, right? So gravity, right? Students got it? Okay. Yes, gravity. Okay, very good. All of you are also sitting and standing. We are all standing, sitting because of gravity. Clear? So here they have mentioned, okay, any deviation from it will cause the stop. It will reduce the growth of a plant. Next thing is very, very important. Who is it? Differentiation, right? Differentiation. Students, I told you there's a slight delay in writing. Do not worry. Don't be like, ma'am, lag, lag, lag. Don't message and spam the chat box. Delay, it will work. Okay. When classes happen, issues happen, right? Okay, so students, differentiation. Now, differentiation, de-differentiation, and redifferentiation. Okay, now this is one very, it's a very, very funny topic. Okay, it's a very funny topic. I'll tell you why. Okay, students, so now we have a primary meristem. Imagine we have a primary meristem. Who is a primary meristem? Who is the first person who is deciding ki, okay, I am going to start the development? Who is that people? They are two brothers. Who are the brothers? Who are the brothers? Tell quickly. They'll decide, okay, I will start growing first. Who is the brother, students? Should I give you a clue? Okay. Vashini, got it. Meristematic cell. Right? Primary meristems are who? Ram and Sam, right? Ram and Sam will be like, okay, I am actively dividing, right? Ram and Sam is actively dividing, helping for the shoot growth, root growth, correct? Okay, root growth. Now, what is happening? This meristematic cells. So, what is the first step? Okay, differentiation is going to happen. What are these meristematic cells? At one point, we will be like, okay, see now every day, can you, like forever in your life, can you always be dependent on your parents? At one point, you have to start going to work. You have to see the reality of life, how jobs work, how salary comes, how, how we have, task in life, right? Can you always be like, oh, I'm preparing for NEET, I'm preparing for NEET. Till you die, can you keep preparing for NEET and, ask your parents to feed you? No. At one point, you have to take responsibility. So same way, we are going to tell this meristematic cell, enough of your acting, stop dividing. Now you have to take responsibility. That is when the first differentiation happen. So what is going to happen? Your meristematic tissues, okay, your meristematic tissues, color do I, yes. Your meristematic tissues, students, color is visible? Yes. Okay. Meristematic tissues will be like, okay, loses its ability to divide. Okay. We are telling them enough. Now now you are an adult. You start taking responsibility. So it will lose its ability to divide. Okay, lose its ability to divide. And after they lose the ability to divide, where are they going to go? They're going to start differentiation or start maturation. Okay, so this portion is called your differentiation. All of you understood or not? Let me know quickly. Did you all understand what I was talking about? Now this will become what? They are going to become differentiated cell, right? They are going to become differentiated cell. Okay, differentiated cell. Okay, did you all understand? Yes or no? Yes, understood, right? Yes, they lose the capacity of dividing and we'll tell them you are now an adult, start doing job, right? So same way we will tell this SAM, RAM or any primary meristem, we'll tell them you they lose their ability to divide and they'll get differentiated, okay? And this process is called differentiation. Clear to all of you? This is a little confusing, that is why I'm stressing so much on it, okay? This is a little confusing, so I'm going to stress a lot about it, okay? Yes. Now students, look here. Okay, look here. This becomes, okay, this people will become nothing but they are going to become your primary, they are going to become your primary permanent, okay, they're going to become your primary permanent cells. Agreed? Agreed? If that cell has lost their ability to divide and undergone differentiation, are they going to form the primary permanent cells? Yes, they are going to form the primary permanent cells. Because permanent cells are what? Cells which will not divide. They will take up a function and they'll just leave like that. Okay. So this, right, this stage from meristematic cell to differentiated cell to form this, it becomes your differentiation. Okay. Clear to all of you? Clear to all of you? Yes, fine. Good job. Good job. All of you understood, right? Quickly hit the like button. Quickly hit the like button. I do not see attendance. I do not see attendance. Yeah, why are you people very conjuicy about this? I don't understand. Are you feeling like, oh my god, my one like is gone? My one like, what if ma'am becomes celebrity? What you people are thinking, huh? David, why are you always in a hurry, David? Why are you always in a hurry? I cannot finish the chapter now. Okay, if you want me to read the NCRT and go, I can do that right now. If you want me to explain every single line of NCRT, I cannot finish the chapter at one shot, right? This is not the time for us to do one shot also, right? Okay, fine. Now, students, differentiation has happened. Now, problem comes. Now, what is the problem? Now, what is the problem? The cells will be like the some parenchyma cells, okay? We will request, who will request? The plant will request parenchyma cells that now you do one thing, you retain your ability because now I want to increase in girth. Now a plant has grown, right? They got differentiated, some function they were doing. Now the plants will request some of the parenchyma cells telling that, can you do one thing? Can you regain your ability to divide? Okay, can you regain your ability to divide? That becomes de-differentiation. That becomes de-differentiation. So what is going to happen? You have your differentiated cell. We are telling the differentiated cells to regain its ability, to divide. Okay, to divide. Okay, to divide. To do what? To do what? This process is called as. Okay, did you all understand? Yes or no? Quickly let me know. Did you all understand? Okay, and what are they going to form? They are going to form secondary meristems because only meristems will be able to divide. Okay, so we're telling them you regain the capacity. After you became primary permanent cells, we are telling them you regain the capacity and you become secondary meristem because now I want to increase in girth. I want to become, thicker. I want to become like a very strong tree. Okay, that is what is happening. Okay, so this becomes, right? This regaining becomes de-differentiation. Okay, this regaining becomes de-differentiation. Okay, clear to all of you? Clear to all of you? Yes. Okay. Yes, correct. Primary permanent cells to your secondary meristems, that becomes your de-differentiation. Now what is happening? The plant has reached one maximum girth. Okay, now plant is like, there's no more space for me. Do one thing, you again go back. You lose your ability to divide and you go back. Okay, you go back. Clear to all of you? Did you understand what is happening here? That this is why I told you this is a very funny what is that function. Okay, now here students, here what is happening? Can I say here, one second, can I say here this secondary growth is happening? Can I say here secondary growth is happening? Yes, secondary growth is happening. That means what? Girth is increasing, right? Girth is increasing, right? Girth is increasing. Okay. Okay. So now the cells will be like, it's okay. Now you go back. Okay. You go back and you lose your ability again. You lose your ability to divide. Okay. You lose your ability to divide. Again, this cells will lose its ability, to divide, and they become, okay, they become what? This process will be called what, students? This process will be called what? Tell me quickly, what will this process be called? Again, they are going to lose its ability to divide. So they're going to perform. They're going to perform a specific function, right? A specific function they are going to form. What is this process called then? Redifferentiation. Okay, this will be called as redifferentiation. Okay, redifferentiation. Okay, now it is like flight takeoff. Now the flight will take off, students. If you're going to, okay. So here, what is happening? Here, what is happening? Here again, okay, the cells are going to be your secondary permanent tissues. Secondary permanent. Clear to all of you? Is this clear? So shall we write the process name also here? Okay. Let's write the process name here. It becomes Dedifferentiation. Okay. Got it? Did you all understand? Okay, let's do a quick summary. Okay, so what has happened? Differentiation, dedifferentiation, redifferentiation. Okay, so there will be meristematic cells like your SAM and RAM. Okay, they will be there. They'll be continuously dividing for a very longer time. At one point, plant will be like, you have to stop dividing. Now you have to get into maturation, or you have to do maturation, right? So this meristematic cells will lose its ability to divide. They'll be like, okay, I'm going to stop dividing and I will get differentiated, or I'll get matured. So that cell, we call it as differentiated cell. Okay, that cell is called as differentiated cell. Now that cell is going to become what? A primary permanent cell, or a primary permanent tissue in plant. Okay, students, the word should be tissue. That is the most appropriate. So I will write here also. Okay. Right. Primary, primary permanent, primary permanent tissue. Now, this primary permanent tissue, okay, they were doing some kind of function. Now, what will happen? The plant will request whom? Some of the parenchyma cells. It will request the parenchyma cells telling that, can you please increase my girth? Can you please increase my girth? Who can do increasing in girth? Meristematic tissue, right? Lateral meristems can do. Now, this differentiated cells will again gain the capacity to divide, and they'll become secondary meristems and start dividing, increase the girth of the plant. So this become dedifferentiation. Clear to all of you? Okay, I'm explaining it again. Hi Ramakrishnan, did you join the Avengers batch? Because today the offers are going to end. I did not see you after that. Okay, I did not see you after that. Did you join the batch yet? Do you use my code? Okay, so students, what is going to happen? What is going to happen? No, not yet, not yet. Okay, students, what will happen? Your secondary meristems, right? Secondary meristems, after they reach one point of girth, no, the plants will be like, enough, enough. I do not have any more space, right? So they will be like, okay, we are going to again lose our ability to divide, and then they will start doing a specific function. Okay, then they will be called as secondary permanent tissue. Okay, that process is called redifferentiation. Okay, is this clear to all my dear students? Is it clear to all my dear students? Yes. Yes. Can you all reply quickly in the chat box? Is this clear? Very important concept. If this is not clear, then you are going to really lose your marks, okay, in this chapter. A very common question also. A very common question also. Okay, now we are going to study with the help of an example. Now we are going to study with the help of an example. Okay, the example. Now let's see what is the example. Okay. The example here, we are going to start with the seed. Okay, we are going to start with the, got it? Okay, from the seed an embryo is grown. Seed and embryo is grown. Correct. Now from the embryo, there is going to be embryonic meristem. All of you agree so much? Seed is there, form embryo. Inside the embryo, embryonic meristems will be there. Who will be there? Sam and Ram will be there. Yes, Sam and Ram will be there. Now, from that, we are going to get a seedling, right? We are going to get a seedling. Okay. We are going to get a seedling. Okay. From the seedling, what is going to happen? After the seedling form, we are going to get our first meristems, right? First meristems. Who is our first meristems? Okay, this first meristems or your primary, okay, primary meristems, not first, I'm telling primary meristems. Students, primary meristems will do what? Will increase the length of a plant, correct? Do you all remember this? I had taught you in maturation, I had explained you this. Primary meristems will be present both in monocot and dicot. Right, monocot and dicot. They will increase in length. Okay, and who will be that? Your Ram and Sam. Ram and Sam. Clear to all of you? This much is clear. Ram, Sam, intercalary meristems, all these people will be doing the primary meristem part. What are they going to do? They are going to increase the length of the plant. Okay, after they increase the length of the plant, then monocot will be like, okay, I'm happy. I want to be a tall grass. I do not want to be increasing in my girth. But will dicots be happy? Will dicots be happy? What will dicots ask for? What will dicots ask for? I want all of you to answer. What will dicot ask for? Monocot will be happy. After that, dicot will be asking for more, right? What will dicot be asking for? Dicot will be asking them to lose. Okay. First, they will lose their capacity to divide. Okay, why? Because we will expect them to start taking responsibility and start doing other functions, right? We will ask them to do that. Okay. After that, what are we going to form? We are going to form our primary. Okay, here we are going to form our primary. Okay, primary permanent. Friends, this is the same thing I'm explaining with an example. Okay, primary tissue, right? Here, what is going to happen? Losing the capacity to divide means, can I write differentiation? Can I write differentiation? Right? I can write differentiation. Correct? Okay. Yes, very good. First permanent tissue. Okay. Now what is going to happen after forming first permanent tissue? Then again, are they going to stop? No, they are greedy, right? They will still expect. What will they expect? What will they expect? Redifferentiation. Dedifferentiation. What will they expect? They will expect dedifferentiation, right? Dedifferentiation they will expect, and the dicots will be like, can you please retain your capacity and increase my girth, right? Increase my girth, right? So here what is going to happen? They are going to do dedifferentiation and they are going to regain the capacity to divide. To divide. Okay, regain the capacity to. Okay, after they regaining capacity to divide, what is going to happen? Our dicot plants, right? This is only seen in dicot. Girth will increase. Okay, girth will. Are they going to stop here? No. After the girth increases, they'll be like, okay, it's enough. It's enough of girth increase. Now you do one thing, you stop. You lose your capacity, right? So they will lose their capacity. Who are de-differentiated cells will lose their capacity. Lose capacity They lose their capacity. And what will they form? What will they form? Why is the Josh very less today? All of you are sleepy because I took a class earlier. All of you are sleepy. Sleepy, not sleepy. Yes, redifferentiation. Very good. So students here, look at, they will become what? After that, they will lose their capacity. But here they are going to become your secondary meristems, right? Here they are going to become your secondary meristems, right? Secondary meristems. Now, what is the example of your secondary meristems? What and all can you think of secondary meristems? Your vascular cambium, core cambium. Remember, I spoke about this in the previous class, right? Example is your vascular cambium, okay? Core cambium, right? Your fascicular cambium. All these people are going to do secondary meristematic growth, right? They are going to help in the secondary meristematic growth. After these people lose capacity, they are going to become your secondary permanent tissue. Okay, secondary permanent to a permanent tissue. Okay, clear to all of you? Is this clear? Very good. Vascular cambium. Okay, secondary permanent tissue. Okay, flowchart is clear. So let's go quickly. Seed is there, embryo is there, embryonic meristems will be there, seedling will be formed, then we will find our first primary meristems, right? In the primary meristems, what is going to happen? You will have your ram, sam, which is there both in monocot and dicot, okay? Primary growth, right? Primary growth happens in the case of length. So length will keep increasing. After length keep increasing, what is going to happen? After some time, they will be like, okay, we will lose our, dividing capacity. Let's do differentiation. After they do differentiation, they are going to become primary permanent tissue, right? Once they become primary permanent tissue, what is going to happen? They will start doing some set of functions, correct? They will start doing some set of functions. After that, sometime later, the plants will feel like, no, we have to do more, right? We have to do more. That time they will ask this permanent tissues to regain the capacity to divide, and that process will be called de-differentiation. Okay, de-differentiation. And this will be mainly seen when the plants will have to increase their girth, right? That time we will get secondary meristem. Who are our secondary meristems? Vascular cambium, core cambium, fascicular cambium. All these people will start doing the job. Then again, after some time, the plants will be like, okay, enough of it. You have increased my girth enough. Now I do not have any more space. So you do one thing, you lose the capacity to divide. So they will lose the capacity to divide and they'll become secondary permanent tissue. And this process is called redifferentiation. Okay, this process is called redifferentiation. Clear to all my dear students? Yes or no? Can I get some fire emoji in the class? Can I get some fire emoji in the class? Quickly. It's a very, very important concept. If you did not understand, please feel free to ask me. Okay. Here we'll have our secondary xylem, phloem. Okay. Phloem, right? Cortex. Since cortex is also called as phylodum. Cortex is also called as phylodum. Okay. Yes. Okay. Shall I ask you people a question? Shall I ask you people a question then? Yes. Ready for the question? I'll explain you all this before that. Ready for the question? Yes or no? Yes, ready. Okay. Students, the question is this much. Okay. Question is this much. Say your, okay, I'll give you, say this now. Here only I'll write it off. Okay, here only I'll write. Okay, imagine Sam. Okay. Cortex. Okay. Cortex. Then say vascular. Yeah. Okay. Now all these people are there. Okay. Now this many people are there. Maybe we can add more. Fascicular. Fascicular. Okay. Now, out of these people, out of all these people, tell me how many are getting differentiated, how many are getting redifferentiated, how many are getting de-differentiated. Okay, this is the question. This is the question. How many are getting differentiated, redifferentiated, and redifferentiated? Tell me quickly. Go from the first one. Cortex, vascular cambium, fascicular cambium. Student, innocent girl code is Gopika. Gopika. You know my spelling, right? Use the code Gopika. Code for Unacademy app. You mean free classes? That will be your phone number and OTP. Okay. Sam, you people are telling it is going to get differentiated. Going to get differentiated. Student, Sam is more of a primary meristem. Okay, primary meristem, right? So we cannot tell that the Sam is getting differentiated. It is more of a primary meristem, right? Yes, cortex, very good. Secondary cortex is getting redifferentiated, correct? Vascular cambium and fascicular cambium, redifferentiated. Very good. Okay, this is more of a primary meristem. Okay, primary meristem. Yes, very good, very good, very good. Good job, good job. Okay, good job. All are answering. Okay, so it is here. If they ask you primary meristem, go for Sam and Ram. Otherwise, if differentiation is asked, you can think about your, about your the normal, the cortex or your interfascicular, more intercalary. Okay, that. So these kind of questions will be asked in your exams. Okay, the questions will not be like what is differentiation. They will not ask. Okay, here they will ask directly. Okay, they will directly ask you what is. They'll give you like this a box and they will expect you to answer that. Okay, clear. Fine. These are the lines from your NCRT. So differentiation, the cells derived from the root apical and shoot apical. What is root apical? Ram, Sam, meristems and cambiums. This is your intercalary. Differentiate and mature to perform a specific function. Okay. This act leading to maturation is called as differentiation. So any cell that was, actively dividing, when they lose that ability, it is called as differentiation. Clear to all of you? Okay. Students, even if you put Sam and Ram in under differentiation, there is no problem. But it is more correct if you put them as a primary meristem, because that primary meristem is capable of undergoing again division, right? They're still actively dividing. Clear to all of you? Yes. Fine. Now look here. Okay. Now dedifferentiation. Plants show another interesting phenomena where the living differentiated cells that by now have lost the capacity to divide can regain its capacity to of division under certain condition. This phenomena is called dedifferentiation. Clear to all of you? Yes? Clear? No? Easy, right? Easy, right? Now, again, tissues, again, redifferentiation. Tissues are able to divide and produce cells that once again lose the capacity to divide but mature to perform a specific function that is called as redifferentiated cells. So that is basically, this is going to become your permanent, right? Secondary permanent tissue. Permanent tissue. Okay. Clear to all my dear students? Yes or no? Quickly show me. Quickly like the session and let me know. Okay. Yes. So this is what we have understood. Okay. This is what you have understood. Now, we are going into a very important thing. Okay. Very important thing. The important thing is nothing but your development. Okay. Your development. So now that you have understood differentiation, redifferentiation, dedifferentiation, now we are going to understand development. So when we talk about development, okay, when we talk about development, say normally students, how does development happen? Starting of this chapter I had taught you. Okay. Starting of this chapter I had taught you. Imagine there is a, right? Imagine there is a seed. Okay, this is a seed, and then later the seed becomes like this, right? And then later again the seed becomes like this. It will start developing, your plumule and radicle will start developing, and then say our plant will get developed first, or a slight more like this. This, say some leaves started forming. Okay, this is just, I'm just drawing it for the understanding only. Okay, seed is forming, and then the plant will start growing properly, right? Full proper root system, everything will start forming. Okay, slowly a bud started forming, right? After that, so these are the phases, right? After that, a flower, I mean, a plant has grown completely. The plant, right? Which also is properly. Okay. Friends, I have to also show you one NCRT flowchart that is given in NCRT. Do not worry, I'm going to teach. Okay. I've added here next. Students, so look here. Your seed, this is the growth, right? This is the growth. After this, the plant is going to die. Now, these are, what is this called? What is this called? This is called the lifespan of a plant, correct? Seed you have kept. After some time, you will see the seed start germinating. Seed will start forming small plumule. From plumule and radicle, it will start forming small shoot and root. After the shoot and root is formed, you can see small leaves coming out. After small leaves coming out, bud will be formed, right? So this is your lifespan. So in this lifespan only, regeneration, degeneration, differentiation, everything is happening, because depending on the environmental condition, depending on the situation, the plant will decide what should be taking place. Is this clear to all of you? The word lifespan is clear to all of you? Okay? Lifespan is clear to all of you? Okay. So students, here, say we start from the seed, right? Here germination is happening. Germination is happening. And here, again, the seed is going to be, say, juvenile phase. Juvenile phase. Okay, from juvenile phase, again, we are going into, say, maturation. Okay, from maturation, again, we will go into reproductive, or we can all say flowering, right? Reproductive phase. From reproductive phase, you have flowering, right? Flowering phase. From flowering phase, plant will reach death or senescence. That means at one point the plant is going to die, right? So it will reach senescence. Agreed or not? Agreed or not? Yes? Isn't this normal? So what is this whole thing called as? This whole thing is called as lifespan. Whole thing is called as lifespan. So in the lifespan itself, differentiation, de-differentiation, everything is happening. Okay, everything is happening. Now, look here. When we talk about development, what is the definition that they're given? Development is the term that includes all the changes that an organism goes through its life cycle, from generation of a seed to the senescence. Okay, clear, right? Very simple. From the seed, from the time we started, like, oh, we plant that, okay, let this plant grow. From that time to the death of the plant is the development, right? To the death of the plant is the development. Here also you can see a seed is there, small roots are forming, then a small plumule, a shoot is forming, right? And it is continuing, and then finally a flower is there, right? Finally a flower is there. This is development. At the same time, what is this? This is also the lifespan of a plant. Also the lifespan of a plant. Clear? Any doubts? Any doubts? No, right? No doubts. Yes, life cycle or your lifespan of a plant. Now, look here, students. This is what your textbook has given. Okay. Students, look here. There is meristematic cells, right? Meristematic cells are going to actively divide. That means cell division is going to happen. Plasmatic growth. Now, plasmatic growth means whenever the cell is ready to increase in size, that kind of growth is called as plasmatic growth. Okay, so plasmatic growth is going to happen. Then the plant, the cell, say the meristematic cells are going to reach your differentiation, right? It is going to start behaving like, okay, it is going to start your maturation, right? Maturation. Now, after maturation, what is going to happen? The cells will form mature cells. Mature cells. Now, during this maturation, or during this maturation, mature stage, we are going to also have our flowering, reproductive, everything, right? Same thing in humans. Same thing in humans. Once we reach a certain age, that is the only time when our reproductive organs will start developing, right? They'll all start becoming functional. Secondary reproductive growth will be seen. Correct? Agreed, all of you? Agreed, all of you? Have you seen a baby with a mustache? No, right? No, right? Have you seen a baby with a mustache? No, right? So that means until we reach a certain age, certain kind of growth will not happen in our body. Same way for plants. Now this is called as development. At the last, death will happen or senescence will happen, right? So here, do not get confused here. Even though the diagram looks very complicated, it is nothing. It is the same thing. Here they just denoted it with arrows. Okay, they have just denoted it with arrows. Now if you see, if you start from here, you have meristematic tissue, right? Here, if you see, you have your meristematic tissue or your meristematic cells. They will undergo cell division. After cell division or the plasmatic growth, directly if you go like this also no problem, plasmatic growth will happen. That means basically the cell will increase in size. Okay, cell will increase in size. Okay, after that differentiation will happen. Differentiation can, after that maturation will happen. Even expansion, elongation will happen. Then they will form the mature cell. At this stage, what is going to happen? Your flowering will happen. Okay, flowering is going to happen, or your reproductive stage. This is okay, reproductive stage. After reproductive stage, senescence will happen, death will happen. Clear to all of you? Clear to all of you? Yes, good job, good job. Fine. So this is clear. This is clear. Now we are going to study a very, very important thing. What is the very, very important thing? Okay, development. How development happens, right? What are the reasons, or what could be, what are the changes that plants does for themselves? Okay, does for themselves. So students, look here. If development has to happen, right, there will be requirements. There will be requirements. Requirements are nothing but if the plant has to, change, right? If the plant, if in the sense, during their developmental stage, right, during their developmental stage, depending on the environmental conditions, sometimes the plant can modify themselves. That means depending on the environmental conditions, right, or environmental conditions, this plant can modify itself, right? Modify itself. Now what do I mean by environmental condition? What could be the environmental condition? Temperature, light, water, okay, all this, etc, 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 whatever we studied in our condition for growth, right? Any of this, if it changes, development will change slightly. Okay, same way, if any of the phases change, that means phases in the lifespan, okay, any of the phases in the development changes, any of the phases in the development changes, there can be a change in the development. That means, what am I talking? Imagine juvenile phase has got damaged, or something has happened internally or externally. Because of it, the phase was skipped, or the phase had changed. Because of it, your development can change. Okay, now this ability is called as plasticity. That means plants follow different pathways in response to the environment or phases of life to form a different kind of structures. This ability is called plasticity. That means plasticity simply means that depending on the environmental condition or the phases in their lifespan, if any changes happen, that ability for the plant to change is called a plasticity. Can we change like that? Can we change like that? Yes or no? Can we change like that? Can we change depending on, like, okay, I don't want to be in my childhood, so I will just directly become an adult. I don't want to be in an adult, so I will just go back to my childhood. Can we change like that, students? Even plants cannot change like that, because we know growth is an irreversible change. But what I'm trying to say is they can do small modification in themselves to survive better in the situation, right? How we do. Now, you people, if you see, now if you like a teacher, you will always attend that teacher's class. You will always be attentive in the teacher's class. If you do not like some teacher, you will behave. That is your behavior, right? That's your adaptation. That's your adaptation. And some of you does not want to crack NEET, who are here for fun. They will come attend 5 minutes class, tell that, ma'am, I want to join this batch, I want to do this much, I want to crack NEET, I want to get into AIMS in like one day. How can I crack NEET in one day? So those are the students who are just here for situation. They're adapting. They're like, okay, they are bored. What will I do? I will get into a live and ask ma'am a very different question: how to crack NEET in one day, right? There are students like that, but there are also students who are very dedicated, so their adaptation will be in such a way to crack NEET. This people's adaptation is to entertain the class, to just have fun. Clear? Clear? Anyone here like that? Anyone here for the asking me, ma'am, how can I crack NEET in one day? How can I get seat in AIMS in one day? I'll give you solution. Anyone like that? Anyone who has such an interesting question? I'm very free to answer. No one? No one? Ah, good job, good job. None of my students are like that. You want to crack NEET in one day? Don't write NEET. Don't write NEET. That is the solution. So you'll not have worry of cracking NEET. You'll not have worry of aims that one seat. Right? Yes. So students, the plant's ability to change depending on the environmental condition or phases of life is called a plasticity. Okay, plasticity. Fine. Now let's study plasticity in a more understanding way. Okay, students, the leaves. So development or your plasticity can be depending on two things. Okay, two factors. One thing, okay, two things your development or your plasticity will behave. Okay, one development. Okay, so what are those things? Okay, what are those things? Now in development, okay, in development, your that is your plasticity can be depending on two characteristics. One could be because of the phases. Okay, phases. One could be because of the environmental changes. This is what we just now discussed. Now, depending on the phases means now they can show one kind of modification in when they are in the juvenile phase, one kind of development when they are in the juvenile phase, one kind of development when they are in the adult phase or in the mature phase. Okay, mature phase. Clear to all of you? Right? Mature phase. Okay. So students, here mainly plasticity happens because of heterophily. Plasticity happens because of heterophily. Okay. Heterophily means what? Heterophily means what? Okay. Heterophily means change in the leaf. Right? Leaf. Now if you look at some plants, they will have two types of leaf. How many of you have seen coriander? Run to your kitchen and find coriander. Fridge. Go to your fridge and find coriander. What do you tell for coriander? Uh, I forgot, students. Okay, coriander. Yes. Yeah, coriander. Okay. So have you seen that? You can see that sometimes coriander leaf will be like this, right? Very, very thin, and sometimes the most of the time the leaf will be like this, right? Your parents will tell, oh, this is not good. This is different. This one is, what is that? Naturally made. This is made differently, right? But that is not the state. That is the adaptation the plant has taken. So look here. The leaves of the juvenile plant are different in shape from those in the mature plant. So here you can see the leaf is different in juvenile, and here the leaf is different in adult. Why are they doing this? Why are they doing this? To make themselves survive the condition. To make themselves survive the condition. Okay, clear to all of you? Example is cotton, coriander and larkspur. Okay, got it? Yes or no? Yes or no? Clear? Very important topic. Heterophily means different shapes, right? Different shapes in leaf. Different shapes which you can see in your leaf. Okay, clear? Okay, great. Okay, now when I talk about environmental conditions, students, now some of them will have different adaptation if they are on the terrestrial, like on the land, and some will have different when they are on the aquatic. That means there could be plants which are like, some part is in the water, some part is on the air. Okay, some part is in the air. Now they will do a kind of adaptation that will let them survive in the water as well as on the air. Okay, as well as on the air. Now let's see that. Let's see that. Look here. Difference in shape of leaf. Oh no. Difference in shape of leaf produced in air and those produced in water. Example is buttercup. Also represent in heterophilous development. That means what? In water, if this kind of leaf is there, what will happen? Because the water currents are continuously moving, the leaf will tear, the leaf will get damaged. So the plant has made themselves in such a situation so that whatever happens, how much of a water is moving, whatever be the waves, the plant will not get damaged. Is this clear to all of you? Okay, example is buttercup. Yes or no? Yes or no? Okay. Yes, very good. Okay, clear all of you. So this is plasticity. So plasticity is of two types. Okay, quick revision. Plasticity is of two types. What are the two types? Okay, first type, depending on the environmental condition, they will change. Depending on the phases of life, they will change. Okay, so depending, plasticity means the ability for them to change. Okay, depending on the situation. So on the environmental condition, if the plant is in water, they will modify their leaves in such a way that the water current does not damage them. Okay, and then if they are on land, they will make broader leaves to survive and to do photosynthesis. Okay, that is depending on the environmental condition. Now when we talk about phases of life, depending on if the plant is in the juvenile phase, the leaves will be smaller, right? The leaves will be smaller like this, right? If the plant is an adult, right, if the plant has reached maturity, right, they are going to be like this. Okay, so depending on two situations, plasticity can change. Yes, are we good to go? Example for the development depending on environmental condition is buttercup, and it is mainly seen as heterophily. That means the leaf will change in shape. Okay, and the example for your phases of life is your cotton, coriander. Okay, cotton and coriander. Fine. Okay. Next one. So students, we are going to see your development, right? How are we going to see your development? With the help of our UAIT exams, right? UAIT exams. So students, your development, that means are you in the juvenile phase, are you in the adult phase of your NEET preparation, we are going to see with the help of UAIT. Students, always remember that you are going to compete with 20 lakh students. Okay, 20 lakh students, 20 lakh plus. Okay, this time I'm expecting around 20 lakh 80,000 students is what I'm expecting. Let's see the number. Maybe it can be very rare chances that it'll be less. Okay, you're competing with 20 lakh students, and this UAIT exam, this one specifically for class 12 and droppers, will help you see where you stand. Now what is the benefit? All around India, right? All around India, whoever has downloaded Unacademy app will be joining your UAITs, and they're going to compete with you. So you will know yourself where you're on the leaderboard, where your rank is. So you will get a confident. If you're feeling like, okay, ma'am, I have reached, say, out of 20,000 students who have written, ma'am, I'm in the thousands. You'll feel the confidence that, yes, if I prepare a little more in this next 5 months, I will be able to, crack NEET, right? Crack NEET, because 20 lakh number, you realize how many zeros are there, right? And if you want a more pen paper based, like how you're going to prepare for your NEET or how you're going to write your exams in NEET, right? So students, your UAATs will be in such a way like you're sitting in an exam hall, right? They will give you a proper time, they will give you a proper reduced syllabus question paper. All this is based on the reduced syllabus. So I would request all my students to attempt your UAITs. Okay, at least give it one time a chance. Give it one time a chance. Even if you're studying from YouTube elsewhere and all that, even if you're feeling like, no, I don't know what is happening in NEET, give your UAIT, see where yourself in your rank. Take your next month to prepare and make yourself better. Okay, and if you use only Gopika code, are you going to get a more discount from this price? Okay, if you use the code Gopika, you might get up to 20, 10, 50, whatever percentage discount that the team is offering you. Got it? So quickly make your decision and join. All the links are in my description. Okay, you don't have to go anywhere. And your today will be your last time I'm going to tell about this, because your time is over to join. Those who are planning, right? Those who are planning to write your NEET in to the 2025, your prices will be this. That means you're going to get around 1 year and 6 months coaching. Students, 1 year, 6 months coaching, and your dream aims will be there. Okay, why? Because quotas, best educators, top educators will be teaching you, will be training you for 1 year, 6 months continuously with mock test papers, with continuous grading, where you stand, what you do. Ma'am, today, sir, I'm not feeling like watching live. They will not let you go. They will not let you go, right? It is like you're going to a school. It is like you're going to a school or a college, and proper educators are there waiting to, take your class. Attendance will be taken, everything will be taken. So 1 year, 6 months, you can just give it to their hand, pay this amount, rest the teachers are going to take care. Okay, studies part you have to only take care. But you're feeling like, no ma'am, I want to write it this year, then your last chance is this. Almost we have 5 months, and your last, the April month, we will be focusing on continuous MCQs, test series, PYQs, chapter based, flashcards, whatever that you need, all the luxuries that you need for your NEET 2024, you're going to get in this price. Okay, 14. And if you're planning to write it for 2026, you're feeling like, no, ma'am, competition is too much. I need at least 2 years and 6 months of coaching. Then you can go for this. Okay. All EMI options are there. How much ever you can pay right now, you can pay rest, you can pay later. So slowly you can do all those things. Whatever help you need with the team, you can call in this number. And if you use code Gopika, you're going to get extra discount from this number. So do not wait anymore, because today will be the last. After this, I will not be giving you any, I will not be talking to you about this limited offers. Okay, so decide yourself if you want to write it this year or next year, and decide yourself if I want to be under, quotas best educators. Do quotas best educators, you have to learn, because you cannot right now travel and be there in the batch. So take the benefits as online education. Okay, I would tell all of you to prefer online education, because students, don't waste your time traveling, don't waste your time waiting for them and all that, right? Now this is easier. Otherwise, on YouTube, you have to wait for part 2, part 3. Ma'am, when will you post that? When will you post this? Okay. But here, that tension is not. Everything will be in your hand. Okay. So, this also, these are the prices again. The same thing. These are the best educators in Unacademy. No doubt. You can go check about them. Okay. They are the best. Okay. And they're teaching right now in Kota also. So, you can imagine how many, the ranks you can see here. We have all got these ranks from these educators. Okay. So if you want to be in your aims, Delhi, Rishikesh, wherever you want, this is your right chance. Okay. This is your right chance. Okay. And you can see here the batch starts on November 30th. So you have another 1 week to decide where you want to be. Again, you should use the code Gopika. Okay. You should use the code Gopika. Otherwise, you're not going to get any discount. Okay, students. So any kind of help that you want, right? Everything will be NCRT based questions. Every single test that they are going to conduct as a batch, everything is going to be depending on your reduced syllabus. Do not even worry. Okay, everything is depending on your reduced syllabus. They're not going to teach you anything extra. They're going to teach you exactly what is an NCRT, but in a more, with their experience, they're going to teach you in a better way, right? Because see, look here, 500 plus live lectures, and they have got this many ranks, so they know what is right. Okay, so you can unlock the price. Batch will start on November 30th, so the offers are going to end very soon. Okay. Yes, so being said that, let's go to development. Okay, make your developmental fast. Make your development to NCR NEET 2024 faster, and make your choices very quickly, because after this, time is not everything, right? Every time will be ticking. There will be seats that will be continuously happening, right? Okay, so development depends on whom? Students, your development depends on whom? Your NEET 2024 development depends on whom? Who and all are your factors? Tell me quickly in the chat box. Who and all are your factors for your NEET development? NEET 2024 development, who and all are your factors? Quickly, let me know in the chat box. Okay. So when I'm talking about plants, yeah, when I'm talking about plants, the people who are going to help, okay, there could be intrinsic factors, and there could be extrinsic factors. Since for everything there is an internal factor and external factor, correct? Internal and external. All of you agree for this, right? Why is there no messages? What is happening? Are you all able to clearly see me? Yes, quickly let me know in the chat box. I cannot see any messages. Okay, you have intrinsic and extrinsic. Okay, now look here, students. Now, when we talk about intrinsic, there can be two types. Again, two types. Okay, intracellular. Okay, intracellular. Yes, all of you are here. Okay, so you are all sleeping. Intercellular. Intracellular and intercellular. Now, what do I mean by intracellular? Now, what are we talking about? Development depends on whom, right? Development depends on whom? Who is going to help in the development? Plants will have intrinsic and extrinsic factor. That means internal factors that will be, regulating the development. At the same time, will be external factors which will be affecting the development. Now, in photosynthesis, yesterday we saw limiting factors, right? Temperature, water, oxygen, carbon dioxide level. All these are limiting factors. So that becomes your extrinsic factor. Now, when I talk about intracellular and extracellular, intracellular means your genetic factors, the genetic of the plant, right? The genetics or the genes of the plant, genetics of the plant will decide the intracellular changes that will happen. Okay. And when I tell about intercellular, I'm mainly focusing on your your phytohormone. Okay, I'm talking about your phytohormones. Students, what is phytohormones? Phyto. Okay, phytohormone, right? So we are talking about this. What are we talking about? Plants can have intrinsic and extrinsic factor. In the intrinsic factor, there is going to be intracellular and intercellular. Intercellular means your phytohormones. Can any of you give me an example of a phytohormone that you have studied? Yes, plant growth regulators. Yes, very good. Plant growth regulators. Give me an example of your phytohormones. Okay, give me an example of your phytohormones. Oxin, amazing, amazing. Oxin, okay, we have lot of them, right? Ethylene, oxin, your cytokinin, so many of it, right? So many of them we have, right? We have cytokinin, oxin, abscinic acid. They're all your phyto. They might inhibit or they might improve the reaction, right? Or they help in the growth or they will inhibit, right? Inhibit something, right? Oxin, cytosine, yes, ABA, ethylene, correct, abscinic acid, gibberellin, okay, all we have, okay? Yes. So students, is this clear? Intracellular means what? Genetic characters. Intercellular means your phytohormones. Extrinsic factors are who, students? Again, temperature, okay, temperature, carbon dioxide, oxygen, okay, water. All these people are your extrinsic factor, okay, temperature, light, right, light. Clear to all of you? Is this clear to all of you? Right? Clear, right? Okay, fine. Now, let's see here. Let's see here. Okay. So, growth, differentiation, development are a very closely related events in life of plant. Broadly, development is considered as the sum of growth. Okay. Oh, okay. It is sum of growth plus differentiation. So, what are they saying? What are they saying here? Very, very important topic. Okay, very, very important topic. They're telling development, okay, is sum of growth, sum of growth plus difference. Friends, why this is the need for an okay, this is the need for a teacher. Why? Most of you will ignore this, right? Most of you will ignore this when you're reading it in the last moment. That is why notes are important. That is why every single line a teacher tells is important. Okay, otherwise you can just read NCRT and score well, no? Score well. No, why most of them are not able to score well in biology? Why do they do 1, 2, 3 attempts? Because biology is not that easy. Like concepts, understanding is easy. Most of you will be like, oh, it's okay, I'll read and understand. Chemistry and physics is very difficult. Yes, every subject has its own difficulty. But biology, what happens? There is a hidden thing that you will not know. Okay. Now this question could be asked in any different way. How is development connected to differentiation? How is development related to growth? Okay, most of them will write development is directly proportional to growth, development is inversely proportional to growth, okay, something like that. But development is what? Sum of growth, sum of every single phase, how much growth is happening, that is your development, correct? So this is why it's important to understand every single line and think of the questions that could come. Ask yourself why, what, how, right? Now, development in plants can be both growth and differentiation is a control of intrinsic and extrinsic factors. Okay, the former means your intrinsic factors include intracellular, which is genetic factors, intercellular factors, which are chemicals, that is your plant growth regulators. Okay, while the latter is your extrinsic factor, which is light, temperature, water, oxygen, nutrition. Okay, these are the same factors we saw in growth. Okay, clear to all of you? Clear to all of you? Yes, ma'am. Good job. Okay, so this is right visible. So clear. Is this clear? Okay. Now let's talk about students. I'm going to start plant growth developers. I will not be able to regulators. Sorry, I will not be able to do the complete thing today because it's a lot. Okay. So we will at least start with oxin. Okay. Before I tell about oxin, let's understand Plant growth regulators can be of two types. Actually, three types, but that one type, okay. Actually, three types. Let this last type be there. Okay, now plant growth regulators. What are they doing? They're doing everything, right? They're doing everything. What are they doing? Everything. What do I mean by everything? They're helping in growth. They're helping in growth at the tip. They're also making sure that senescence does not happen fast. Abscission does not happen fast. The seed is formed. The fruit is formed, right? Plant growth regulators are everything. It is how fast our brain is working, right? Brain is telling me talk like this. Brain is telling me do like this. Everything is so fast. Same way plant growth regulators are everything for the plants. Clear to all of you? Now, plant growth regulators could be called, they can be separated depending on as growth promoters, okay, growth inhibitors, and this one is actually dual nature. Dual nature means they act both as promoter as well as inhibitor. Okay, so now if I have to split them, right, if I have to divide them, got it, if I have to divide them, I will write, so growth promoters means what? They're going to basically help with all the growth, right? They are like the positive people, right? They're going to help with all the growth. Now what are the growth that I expect? Elongation, okay, germination, okay, then differentiation, okay, differentiation, right? These are the things I expect. These are the things I expect, right? When I talk about inhibitors, what do I expect? What do I expect from inhibitors? Can all of you tell me? Yeah, that is Nandini. I'll tell you. Nandini, I'll tell you. Okay, that is suspense. Shouldn't ask suspense in the class. Okay, so yes, what do we expect? We expect abscission, right? That means what? What is abscission, students? What is abscission? Okay. Okay. What is abscission? Can all of you tell me what is abscission quickly in the chat box? Right, abscission. That means what? Leaf, avoiding leaf from falling, right? Fall of leaf or leaf fall. Okay, fall of leaf. And then what do I not expect? Senescence to happen late. Who is going to do inhibition? Dormancy. That means when the seed has to stop, like they will stop the seed from germinating, right? They will stop the seed from germinating. Okay, so we have abscission, senescence, dormancy, right? All these things we have. All these things we have. Then dual nature, both promotion, they promote as well as they inhibit. Okay, now let's write the example. Let's write the example. Okay, example. Now, can you think about which are the hormones that is helping for elongation, differentiation, germination, everything? Okay, who's the people who is going to help? Who's the person who is going to help? Second, students. Chat. Okay. Yes, who is the person who is going to help? Oxin. Oxin. Okay. Then, right, oxin. Then cytokinin. Okay, cytokinin. Right here, who is going to help? Here is going to, who is going to help? ABA, abscinic acid. ABA is going to help. Okay, these are the examples. Okay, abscinic acid, right? Abscinic acid. And dual nature is by your ethylene. Dual nature is by your ethylene. That means it can do both promotion and inhibition. Okay, inhibition. Nandini, doubt clear? Doubt clear? Ethylene has a dual nature. That means it's able to promote as well as it's able to inhibit. Right? Right? All of us are ethylenes. We only compliment, we only, tell negative about a person, right? A person, a thing, right? Correct? We are all ethylenes. We are all have dual natures, right? Ethylene. So it will only promote. It will only tell, okay, I'm going to do this. It will only stop. So it has dual nature. Okay, it is more of a gaseous hormone. Okay, clear to all of you? Cleared all of you? Did you all write it down? Did you all write it down? Yeah, your what is that? Students, most of the, like, when we talk about plant growth regulators, they might have a negative, like they might have a negative impact, but then they are going to favor positively for the plant. Okay. Now we get our adrenal, okay, adrenal rush, we tell, no, that is during our flight or fight, right? But that is actually a help. Otherwise, when someone is attacking us, if our hormones are not working, right, if the hormones, if it's not giving us enough stress, if we are not sweating when we are going for an interview, or if we are not sweating before entering an exam, how will we know our body is normal? So that is, when we look from that point of view, it is a negative mechanism. Why? Because we are sweating, we are getting stressed, we are anxiety is happening, all that. But some amount of this is required for our body. Clear, Nandini? Some amount of this is required for our body. Our body needs some amount of stress. Otherwise, we cannot work. Can you imagine a person who is completely calm? Completely calm. No tension, no stress, no nervousness about anything. They will not have any motivation to live, right? They'll get bored of their life. So that's why some amount is required. Okay? Yes, fine. Okay? Yes. Now, let's go to our students. Look here. Look here. You can look here. You have ethylene, okay, gibberellins, auxins, cytokinins, okay, polyaminins, absinic acid, nitric oxide, salicylic acid, okay, jasmonic acid, all this, steroids, okay. For you, only these things are mentioned, okay. We are only going to do these things, okay. This five we are going to do. Got it? This five we are going to do. Yeah. There are people like that. Some people, no stress. Don't think anyone is there like that, but yeah. Let's hope there are more people. Okay, so students, look here. These are the five things that we are going to do. So we'll be doing one by one. Okay, one by one. So let's see what your NCRT is telling. So plant growth regulators are small. Okay, plant growth regulators are small. They are small, simple molecules of diverse chemical composition. Okay, they could be indole compounds. Okay, indole 3-acetic acid, that is your in oxin. Okay, adenine derivatives. Okay, N6, and derivatives of carotenoids. Okay, absinic acid, terpenes, gibberellic acid, or gases like ethylene. Okay, plant growth regulators are various described as plant growth substance, plant hormones, or phytohormones in literature. So in NCR, in your NEET, they can give any of this word and ask you, expect you to tell the answer. Okay, they can call it plant hormones, they can call it phytohormones, they can call it plant growth substance. You should understand that all of this is related to plant growth regulators. Cleared all of you? Cleared all of you? Yes, fine. Okay, now we will start with oxin. Okay, we will start with oxin. Before that, let me just tell you, students, in when we talk about hormones, okay, when we what? Okay, we are going to see many things. I don't know how many I can write here, but I will just write how many I can remember. Friends, we will be looking at the discovery. Okay, we will be looking at the chemical nature. Chemical. Be looking at their function. What actually are they doing there? Okay, what are they actually doing there? Okay, and we will also look at their precursors. Precursors who are going to help them. Okay, and we will also see about, okay, their psychological role I told you. We'll also see about how they were extracted. We will also be seeing about their commercial. Okay, these are the things that we will be seeing in hormones. So anytime I miss any of this one point, please remind me. Tell ma'am you didn't tell precursor for this, or ma'am you didn't tell the function of this. So we are going to go into that order. Okay, we are going to go into that order. Okay, so shall we start? First we are going to oxin. Now oxin, I have written whatever is from your NCRT. Whatever extra is there, I will let you know. Okay. So students, oxin was derived from a first Greek word. Okay, Greek word called oxine. Okay, oxine. The E pronunciation is not there. It was first isolated from human urine. Okay, this was first isolated from human urine. So the extraction was from where? Extraction was from human urine. One point we cleared. Okay, extraction. Now, the term oxin is applied to an indole 3 acetic acid or your IAA and to other natural and synthetic compounds. So, understand oxin, when we talk about oxin, we can split oxin into natural and synthetic. Natural, synthetic. Okay, are you all with me? Sleepy? Bored? No, right? No, right? It's an interesting topic. Okay, we are going to study how a small thing like oxin can make so much difference. Right? Clear? Fine. Okay. So, students, look here. Oxin can be natural or synthetic. Under natural, we have IAA. What is IAA? Indole 3 acetic acid. Under synthetic, we will have 2,4-D, 2,4,5, okay, 2,4,5-T, okay, and NAA. NAA. Okay, these are the people. Okay, these are the people. That means what? Why only Nandini and Subhashini is not feeling sleepy? I want all of you to reply in the chat box. Come on, put some energy. Come on, show some energy. See, I can only see blue profile. Nandini, Subhashini. Nandini, Subhashini. Why? My other students are not happy. Ah, I can see some pink. Come on, make it colorful. Make your, other than blue, let's have more colors. Some more colors. Yes, good job. Okay, so students here, natural oxin, natural and synthetic. Oxin natural can be IAA, that is your indole acetic acid, and we have synthetic 2,4-D and 2,4,5 T, N and NAA. That I will do in the next slide. Okay, so it is nothing but your dichloroacetic, dichlorophenoxyacetic acid and your trichlorophenoxyacetic acid and your naphthalene. Okay, these are the things. So here synthetic and natural, here they have mentioned. Okay, here they have mentioned, but they have not given it very clear. Okay, now the precursor. Okay, the precursor here only I'll write precursor for oxin. Anyone know? Tryptophan. Tryptophan is a precursor of oxin and it requires zinc. Okay, it requires zinc. Okay, clear? So we understood from where the name was derived. It was a Greek word. They can ask you, is oxen derived from a Latin word, Greek word, Indian word, whatever. So Greek word. Okay, and the term oxen is applied to indole 3 acetic acid. So oxen can be divided into natural and synthetic. Natural, we have indole acetic acid. Synthetic, we have 2,4-D, 2,4,5 tri or T and NAA. Okay, dichlorophenoxyacetic acid, trichlorophenoxyacetic acid, and naphthalene. Okay, naphthalene acetic acid. Okay, now they are generally produced by growing apex. Okay, and of the stem and the root, and where they migrate to the regions of their action. Okay, so you can imagine oxygen are growing promoters, so they should be present in the apex, right? Okay, now look here, this is what I was just talking about. So this is 2,4-D, that means dichlorophenoxyacetic acid. Okay, and 2,4,5-T, that means trichlorophenacetic acid. Okay, trichlorophenoxyacetic acid, and then we have NAA, which is the naphthalene acetic acid. Is this clear to all my students? Yes? Yes or no? Clear? Yes, very good. Okay, good job. So we have 2,4 that is coming under synthetic. Okay, and we have IAA, IBA in your natural, and 2,4-D, 2,4-tri, NAA in your synthetic. Okay, synthetic. Take A and NAA. Okay, these are the people. Okay, yes. Now let's see how did they find it out, right? How did they find it out? So students, I'm going to show the experiment to show the experiment here. So the discovery of oxygen was first done by our Charles Darwin and Francis Darwin. Okay, so you'll be thinking, huh, ma'am, they came here also. Yes, they did come here also. They are in botany also. Darwin's finches, okay, finches. So Francis Darwin and Charles Darwin, these two people found out there was something called as auxin, right? How did they find out? Look here, they found out like this, students. Imagine, imagine this is tip, okay? They use this portion, okay? What is this? Coleoptile, okay? Coleoptile, plumule, right? Coleoptile. So they first kept coleoptile and they started supplying unilateral light. What is unilateral light? Unilateral light. That means light in one direction. One direction. Okay. All of you? Yes. Okay. They are everywhere. Yeah. Okay. So students, they took the coleoptile or the tip, right? The plumule will have coleoptile, right? They took the coleoptile. They passed unilateral light or the light which goes in one direction. They noticed that this one bend. Okay. They noticed that this one bend. Okay. And the bending, okay, I will just write the answer here. It's better than I will just write the answer here. For you. So here what happened? Bending was seen. Bending was seen towards whom? Bending was seen towards the light, right? Bending was seen towards the light. That means actually their experiment was mainly based on phototropism. But then from phototropism, they were able to find auxin. Okay. While they were doing phototropism, they came to a finding of auxin. Okay. This was the first experimental setup. First experimental setup. Second experimental setup. Let's follow. Okay, second experimental setup. What did they do? They did one thing. They took this. They cut it off. Cut it off. Now it became like this. And to this they kept giving light. Again, you need so I'll write 1D. Then 1D. Okay. 1D. Clear? You're able to see, right? Yes. So yeah, by chance the discovery has happened. Okay. So here also they gave the same unilateral light. Okay, they gave the unilateral light and this is 1D. So I'm writing 1D. And what did they notice? They saw no curvature. They saw no curvature, no bending towards the light. Nothing was seen. Okay. Then this was the second experimental setup. Okay, second experimental. Okay, now we will go to the third experimental setup. Are you all understanding? Yes or no? Quickly let me know. Is there anyone who's not understanding? Okay. Everyone understood? Okay, fine. Okay, so students, the second setup, we used a coleoptile. Okay, so in the first setup, they took the coleoptile, okay, and they passed unilateral light. And after they passed the unilateral light, they were able to see the bending. Okay, bending, that means curvature was seen. So they understood that, okay, this is doing phototropism. They're moving towards the light. Second, what did they take? They took the same thing. They cut off the top portion. They cut off the apical portion, right? They cut off the apical portion and they kept only this portion, this much, and they still passed the unidirectional light. No curvature was seen. Okay. Now we are going to talk about the third setup. On the third setup, they took the same thing and they put a cap. Okay, they put a cap. They put a cap and they passed the same direction, that is 1D light, and they noticed that no curvature. Just no curvature. Okay, clear? And the last setup, okay, the last setup. These were the setups, okay? They were trying one setup. Yes. The last setup, fourth setup, they again took the same thing. They covered it with a foil. They covered it with a foil. Again, passed the same unilateral light. And again, what did they notice? Curvature. Curvature. Now, what do you understand from the experiment, students? What do you understand from the experiment? So here, the normal situation, right here, they cut off, right? They cut. Here, they capped. Here, they used a cap. Here, what did they do? Foil. Right? They used a foil. What did you understand from the experiment? What did we understand from the experiment? Just looking at the experiment, what did you understand? Tell me quickly. So, here, and students, I have to tell you what are the things that they used. The one that they used was your canary grass, okay, responded to unilateral illumination of growing towards the light source, that is phototropism. And after a series of experiments, it was concluded that the tip of the coleoptile was a site of transmittable influence that caused the bending of the curvature. They understood that there was at the tip of the coleoptile, something was present that was helping them for the bending. Okay, that was helping them for the bending. As they cut them or they capped them or they used a foil, they were able to understand that phototropism wasn't happening. At the same time, there was something that was obstructing. So then they found that Oxin was isolated by Francis. Went from the, I mean, Oxin was isolated and went from the tips of the coleoptile of an oat seedling. Okay, how did they isolate it? From the tip of the coleoptile of an oat seedling. Okay, so here they use the granary grass. Okay, they use this. Is this clear? Experiment is clear? Yeah, they noticed that there was something present in the tip of the plant that was allowing them to do phototropism, after which they did not see phototropism. They also they understood that maybe this is an hormone that could help the plant to grow, or it could be a hormone that is helping the plant to react to phototropism, right? All this they thought. Okay, okay, students. Oats, you people don't know oats. Oats. Yeah, how many ads comes? Eat oats to become thin. Oats to do that. Right? That only oats plant. Same thing, students. Oats, where we get oats, no? That is a oats plant. Okay? It will look like grass only. It will look like grass. It will look like a grass with a small, like this, like this one seeds. Okay? Oats plant. Clear? It is in your Poaceae family. Poaceae family. Got it? Harsha, got it? Oats? Understood oats? Yes. Okay. So this is the experiment. So this is the discovery. Got it? Discovery is clear. So what now happened? Charles Darwin and Francis Darwin, they were trying to find out phototropism. At that time, they took a grass, okay, and they took the grass and they kept the coleoptile. They kept the coleoptile with unidirectional light, okay, and they noticed that in the first situation there was bending of light and phototropism was seen, okay. And then what did they do with the same thing? They cut off the top portion and checked, and they saw that no curvature was seen or no bending was seen. Okay. Again, they kept the plant, they covered it with a cap, they passed on light, they saw that again no curvature was seen. Okay. Again they kept it, again they kept the grass, they covered it with a foil on the top of it. The still the tip is there, okay, but then it was covered with foil. They saw that again no curvature is there or no phototropism is being shown. So then they realized there could be something that will be there in the tip of it, and then they went to the discovery of Oxin. Okay, then they went to the discovery of Oxin. Clear to all of you? Clear to all of you? Okay, here I was supposed to draw the experiment, but never mind, I drew it here. It's clear, no students? Do I have to draw it again? Okay. Now, I think I'll just what is all did we took as equipments we used? Lateral light, experiment this, passed on light. Okay, all of you can write with me. So your work also will be done. Okay, when I am writing, please write with me. Okay. They took this step. Okay, what happened? Saw that bending words. Guys, good. Go here. All of you are writing with me. And let's go to the second scenario. Second scenario. So we do the same thing, but we cut. Okay, we cut the tip. Got something like this. To this we passed on light. This we passed on 1D light, and we see that no curvature. No curvature. Half a mind. And third instance. All of you write with me so that you do not have to wait for my notes. Third instance, they use the same coleoptile. Okay. and they capped it. Okay, capped it, right? And what did they notice? Passed a unidirectional light. Okay, unidirectional light. Did he or no? Okay, and the last ever instance, right? The last ever instance. Voice is not clear. Only for Kamal, voice is not clear. Or is it for everyone? I think voice is clear. Last instance they took like this, okay, and here they used foil. Again they passed on the 1D. Okay, so no. Here, okay, no curvature. Okay, here they use. So this is the experimental setup. So then they came out with a finding that okay, something has gone wrong. So what is the something? Oxin was Okay, oxen was found at the end of the experiment. Okay, clear to all of you? Now let's see the psychological role or the function. Okay, function, let's see. The students' function, when we talk about function, they helped to initiate rooting in stem cutting and an application widely used for plant propagation. Okay, they initiate rooting in stem cutting. That means once the stem is cut, right? Have you noticed all this? Stem is cut, they will help the root formation on the stem itself, right? Stem itself, right? Okay. Sometimes there is a delay. Huh? Okay. Auxins promote flowering. Auxins promote flowering. Okay. Very, very important. Auxins promote flowering. Example in pineapples. They help to prevent fruit and leaf drop. That is what they do not. They make sure that senescence does not happen, abscission does not happen very quickly at the early stage, but promote the abscission of older. That means if they know that this plant or this leaf is older, they will allow them to do abscission. Like it will promote abscission. Okay, promote abscission of older mature leaves, and but at the early stage they will maximum try to inhibit any kind of abscission or senescence that is going to happen. In most higher plants, the growing apical buds inhibit the growth of lateral axillary bud, and this phenomena is called apical dominance. Very, very important. Very, very important. Kamal, check your internet, Kamal. My voice is clear. Yes, voice is clear. Okay. Yes, students. So in most higher plants, the growing apical buds, what is happening? Growing apical buds is inhibiting what? Lateral or axillary buds to grow. This is called as apical dominance. And apical dominance is done by whom? Auxin. Apical dominance is done by whom? Auxin. Clear to all of you? Yes. Is this clear? All of you quickly let me know if you have any doubt. No doubts, right? Okay. Since apical dominance can also be called as correlation or correlative inhibition. That means buds are the same, right? They are correlated with each other. But then what are they going to do? The buds which are on the tip will try to obstruct the growth of this bud. Okay, clear? Any doubt so far? Any doubt so far? No, right? Which one you want me to explain? Apical dominance, Asha? So students, apical dominance. So here, auxin, what and all it's going to do, it's going to initiate rooting if there is a stem cutting. That means we have taken a stem portion cutting for propagation, right? For vegetative propagation, if we have done that, auxin will make sure that the root is growing. So the plant will develop, right? And then auxin promotes flowering. Okay, and also auxin makes sure that senescence or abscission does not happen in a very early stage, but in an old mature plant, right? Old mature plant, they will make sure that abscission and senescence will happen. Okay, now in most of the higher plants, what happened? The growing tip, okay, the growing tip here, right? This growing tip, you want Oxin, Harsha, you want only Oxin explanation? Okay, so students, here in the growing tip, this growing tip will allow or will obstruct or inhibit the growth of this axillary bud. Okay, this kind of behavior is called as your apical dominance. That means dominance over the apical, okay, at the top. Okay, total, what is total? I didn't get you, Harsha. Be specific. Okay, a phenomena called as apical dominance. Okay, this can also be called as correlative inhibition. Correlative inhibition. Clear? Okay, so this bud will make sure that this axillary or this lateral bud does not grow. This is done by Oxin. This is done by Oxin. Clear to all of you? Clear to all of you? Okay. Yes, we have completed Oxin. We have completed our Oxin. Okay, our right. We have completed our Oxin. Friends, I haven't left a slide for rapid fire, so I'm going to just do it here. Okay. Here. Rapid fire. Ready? Ready, all of you, rapid fire? If I have to start rapid fire, what do I have to see in the chat box? Please let me know. What should I see in the chat box? Tell me quickly. Ready? Yes. Okay. Start. Shall we start? Give me an example of synthetic. Give me an example of synthetic oxin. Example of synthetic oxin. Give me an example of synthetic oxin. Synthetic oxin. Example. Very good. Very good. Why all of you are telling the same answer? Why can't there be different answers? There are so many. 3 of them are there. Very good, Subhashini. 2, 4D. Okay, NAA. All of you have stuck to NAA. 2, 4D. NAA. Then, very good. 2, 4, 5. Good job, Nandini. Good job, Subhashini. YS, Sona, Govinda. Okay, Harsha. Very good job. Okay, next question. Next question. Give me an okay. Give me an example. Give me an example of a secondary permanent tissue. Secondary permanent tissue. Example. Secondary permanent tissue. Good. Secondary cortex. I want different answer. I don't want all of you to stick to the same thing one person tells. Secondary cortex, secondary cortex. Other things? Secondary xylem, secondary phloem, right? Third question. Third question. Tell me the stage after germination in the lifespan of a plant. Tell me the stage, phase, phase after germination. Germination. Good, juvenile. Good, juvenile phase, right? Juvenile phase. Okay. Last one more question. Let me see. Who is the precursor for Oxin? Who is the precursor for Oxin? Precursor of Oxin. Very good. Juvenile phase. Very, very good. Precursor for Oxin. Very good. Very good. Cryptophan. Very good, Subhashini. Govinda, ABA itself is an this one hormone by itself. I'm asking precursor. Precursor. Cryptophan. Right? Cryptophan with the help of zinc. Right? With the help of zinc. Okay. Last question. Last question. Okay, I mean plasticity shown depending on the environmental condition. Example, which plant shows environmental condition plasticity development, right, depending on the environmental condition? Very good, Buttercup. Very good, Buttercup. Govinda, what happened? Everything is going wrong today. Didn't attend the class. Buttercup, right? Buttercup. That means aquatic and terrestrial, right? Aquatic and terrestrial. What will be the example for your this one? Faces. What will be example for your faces? Faces. What is the example? Cotton. Very good. Cotton. Faces will be cotton. Yes. So yes, we have come to an end of the session, students. So next class, I think maybe one more video will go because my throat is not that great. It's not doing that great. Otherwise, I could have taken for a very long hour. But then yeah, throat is not very great. So because of that, we will have to go for one more, maybe part one or part one more part. Okay. So do not worry, I'll be taking families as well. Even if I'm stopping this part here, I will do the rest in this class. Whatever it is, I will let you know on the Telegram channel. So if you still haven't joined my Telegram, you can go and join. Okay, Biology by Gopika channel, you can join. There you will get all the updates about the batches, Telegram, Unacademy, free classes, everything. Okay. So thank you so much, students, for joining. Quickly like the session, share with your friends, and if you are planning to join for any batches, let us know quickly because after this the offers will not be there. Okay, on a serious note, if you're preparing and you want to be the best among 20 lakh students, then this is your last chance. Okay, and you're going to get classes from the top educators, so you do not have to worry. Got it? Got it? You can check about all these educators on the Unacademy app. You can check otherwise also. You will get all good information about them and you can see the ranks here. Okay. Now, thank you so much for joining. I hope you enjoyed the session and quickly, yes, quickly, very good. Quickly like the session, share with your friends, ask all of them to join. Okay. And give so much love, right? Give a lot of love. Yes, thank you. Thank you so much, students. See you all. Take care. Bye.